All right, let's get into it. There's this hidden, kind of invisible conversation happening all the time, all around us. It's a constant back and forth between servers, and it's the core reason the digital world we all depend on stays perfectly in sync. We're going to pull back the curtain on that today.
So, have you ever really stopped to think about how that works? I mean, a change happens on one single server, and almost instantly, a whole bunch of other servers just seem to know about it. How does that message get passed along so fast and so reliably?
Well, you guessed it, it's not magic. It's actually this really clever self-managing system that works kind of like a dynamic contact list. Each server keeps its own private little black book of who it needs to ping when something new happens.
Okay, so how does that relationship even start? It all kicks off with something we can call the first handshake. This is that moment where the contact list gets its very first entry.
First things first, let's get our players straight. You've got a source server. That's the one with the original important data. And then you have a destination server, or what we call a replication partner. Its whole job is to get a copy of that data, and more importantly, stay up to date.
Now here's the part that might surprise you. You'd think the source server, the one with all the data, would be the one starting the conversation. But nope, it's actually the other way around. The destination server makes the first move. It reaches out and asks for changes. The source then goes, "Oh, a new partner?" and adds it to that private notification list we were talking about.
And that special list, it has a technical name, the reps2 attribute. The easiest way to think about it is just as the source server's outbound mailing list. It's a simple local record of everyone it needs to tell when an update happens. That's it.
So, the list is built, the contact is in the address book. Now what? Let's look at how the source actually uses it to spread the news, because this is where the real efficiency of the whole system kicks in.
And this is it's elegant, right? When a change happens, the source doesn't just start shouting to the entire network. No way. Instead, it just calmly looks at its reps2 list and notifies only the specific partners who have asked for updates. This cuts down on so much unnecessary network chatter. It's incredibly efficient.
Now, to really get this, it helps to look at reps2 and its counterpart, reps from. They're literally two sides of the same coin. Reps2 is the sources list. It answers the question, who do I need to tell? But reps from, that's the destinations list. It answers the question, who do I need to ask? See the difference? One's for telling, the other's for asking.
And here is an absolutely crucial point. Each server's reps2 list is its own private business. Like the slide says, it's stored locally. It's not copied or shared across the network. My list of who I need to notify is mine, and mine alone. Your list is yours.
But things change, right? This isn't a static system set in stone. It's actually really smart, and it's built to adapt when things get rearranged.
So, let's throw a wrench in the works. What if a destination server just decides it doesn't want instant updates anymore? Well, it can basically put up a big digital do not disturb sign.
How does it do that? Well, there's a specific setting called the never notify option. When this little flag is set on a connection, the destination is essentially telling the source, hey, thanks, but no thanks. Don't bother calling me with updates anymore.
And this is where the system's self-healing nature just shines. It's so cool. The next time the source tries to send a notification, it gets an error back, but it's a smart error. The source knows to interpret that error as a signal, a message that this partner doesn't want calls anymore, so it just automatically removes it from its contact list. All by itself, no human intervention needed.
Okay, here's another super common scenario in big networks. Servers move. Not always physically, but they might move to a different network site. So, what happens then?
Well, in this case, another automated process. Think of it like a network traffic controller. Steps in. It's called the KCC. The KCC sees that a server has moved, it figures out the best new ways for data to flow, and as part of that whole process, it automatically tells the old source server, hey, you don't need to notify this partner anymore. And just like that, the old entry on the reps2 list gets cleaned up.
All right, let's zoom out. We've gone through the nitty-gritty of how this works, but why does any of this actually matter? What's the big picture here?
The key takeaway really is just how elegant and automated the whole thing is. You have servers building their own super targeted lists. Those lists are dynamic and they even correct themselves. And the end result is that your data stays consistent across the board, all without a human having to micromanage every little connection. It's brilliant.
And that's really the secret sauce, isn't it? This constant, automated, invisible conversation, all built on these simple requests and private lists, is a fundamental reason why massive, incredibly complex digital environments can actually stay stable and synchronized.
So I'll leave you with this thought. This is just one of these hidden processes that are happening every single second. It makes you wonder, right? What other invisible conversations, what other automated systems are quietly working behind the scenes right now to make our technology just work?